Okay. Okay. So it's a great pleasure for me to be here to talk about Julia language with the Latinx game community. I'm Leticia. Uh, I'm a first year PhD student at Carnegie Mellon. I'm Brazilian. I'm 21 years old, and I'm currently working on the development of new electronic structure methods with the goal to speed up quantum chemical calculations using machine learning, artificial intelligence, and GPUs, and in the near future, quantum computing, I hope. So, um, yes, I don't know. I don't think we will have time to everybody go through their intro, but I would appreciate to know a bit more about you. So I will launch a poll here in the Zoom, so you can choose pick one answer about some of the questions that I will be asking. So first, I will ask about everybody careers stage, if it's undergrad, master's, PhD. Just a second with the poll. Yes, there you go. Can you see the poll in the screen? So I would appreciate if everybody could answer. Yes, cool,
Yes.
nice. Oh, cool, everybody answered. So okay. Oh, we have a lot of masters and PhD students here. So yeah, we know how fun and how difficult it is to be in a graduate program. So congrats to you all that are doing this. Yes, and I like the idea to build a community in Latinx game with other graduate students, and I'm sure we can support each other um, on our research and our day-to-day battles. So yes, and oh, I see we have professors here. It's an honor for me. So thank you so much for answering the poll. Okay. So I sent an email last week requesting some stuff before we start the course. So I asked everybody to create a GitHub account, install Jupyter, install Julia. I don't know if everybody could make that or not. But we will have time to discuss about it. I will start sharing my screen to show and explain how this course will work. So I'm sharing my screen. Okay. So as I told everybody in the email, the course will take place on GitHub because I think it's a good way to keep on track with questions, with updates on the code we are working, group projects, because we will have some group dynamics in this course, because this is supposed to be fun and a good moment for us to practice coding and, if possible, and if there's time, talk about some computational chemistry using Julia. First, we will go through the fundamentals. So today we will be talking about Julia, the Julia community. How can you learn more about Julia? How to configure the Julia setup, the basics about the syntax, controlling types, writing functions, managing packages, and some of the Julia features like multiple dispatch. So this is what we will cover today. And this course will have 6 classes, or better saying 5 classes and 1 joint project at the end. So tomorrow we'll be talking about data structures, managing files, plots, scientific plotting, managing CSV files, data frames, and all of this. And this is important not only for computational chemists, but for experimentalists as well, because everybody has a bunch of data to plot, manage, and make operations on it. The day 3, we will talk about numerical computing, parallelization, and GPU computing using Julia. Those are very interesting features we have, and those are useful for molecular dynamics, artificial intelligence, machine learning, and so on. And the day 4, we will use some Julia packages for molecular modeling, molecular dynamics, and quantum chemistry, like DFT calculations. We have some DFT packages implemented in Julia. Those are very incipient, but they are useful to start working with. And in the day 5, we will be talking about machine learning and deep learning. And in the last day, we'll have a joint project and we will go through a paper. I'm still trying to find the best paper for us to go through, but the idea is to use Julia to reproduce some of the results of one of the artificial intelligence in chemistry papers that we have. But I will keep asking about this during the classes to see if everybody is down to do it, because I think this is a good activity for us in the last day, putting practice together all the knowledge and things we discussed. And also it will be a fun activity to finish this cycle. If you go to this, I will put the link of this repository in the chat so everybody can follow me. Questions so far? Oh. Let me paste the link here. Okay. Yes. So I think everybody can follow me now if they click on this link on GitHub. Probably this repository will show up. And if you have questions during the class or after the class about the things we are doing here, you can go to this tab here, issues, and you can open a new issue. When you click on opening a new issue, I will put an example question. And then you put in the description, I was trying this code And then you use markdown notation to do this. And it did not. And then you go to preview. You see here, you can just write the question. You don't need to put code. But this is an example, and then you click on submit new issue. And then this will be public to everybody in the class, and I think we can discuss the questions everybody has while learning Julia here, and we can keep on track. Once the question is answered, we go here and we close the issue. Yes. And then some things about this collective interactions. I think everybody can, since everybody can see the questions and answer them, I think everybody needs to be respectful in the questions and answers, because this is supposed to be a friendly environment and everybody's learning, so nobody's supposed to know everything about this, and we can find out the answers together, because I don't know everything, nobody knows everything, so I think we need to keep this a friendly and nice environment for everybody to be in. So, questions so far? If you have questions, you can open your microphone. Don't be ashamed. Or ask in the chat as well. There's no problem with that. Let me open a new book. Okay, so I will be asking in a new poll if everybody has access to it, to this repository. Launch. So let me stop sharing, just to make sure we are all on the same page. Okay, so I will put another poll just to make sure everybody knows what we are talking about. Okay, everybody has access to the course repository. That's great. So here I will launch a new one. In this one, I'm asking the experience everybody has with Git and GitHub, just to make sure everybody knows what I'm talking about when I say GitHub and Git. Okay. Okay, sounds good. Okay. Okay, I see most of people are beginners and intermediates. That's great. I think we won't be using advanced features of GitHub in this course, but some of the basics are good, but we are here to help each other. So if we have issues using that, we can ask each other, open the issues as I showed, and there's no problem with that. So I suggest everybody. Oh, I see a question in the chat. So Laura asked if the video is going to be available once the meeting is done. Yes, as soon as I have it in my email, because after the meeting ends, I get the recording in my email. Once I get that, I can make it available to everybody. Okay. Did everybody understand this part? Question so far? Okay, so I will share my screen again. So I suggest everybody now to take that link of the repository, the link in the chat, and run a git clone on that repository. So you'll have the code on your machine. I will give 3 minutes for people to do that. And then I will launch a new poll to ask if everybody could do that. Does it sound good?
Yes, it's okay.
Okay. And let me know if you have problems doing that. I'm here to try to help as much as I can.
No,
Estos pelados que están haciendo las prácticas de laboratorio, que semestre son, ¿a qué semestre llegan ellos?
son como de octavo,
O sea, ahí
de séptimo hasta décimo.
O sea, son de séptimo en adelante.
Sí, porque había un pelado de tercer semestre y yo eso le dije, no, tú no vas para allá porque
No, yo te estoy preguntando eso para saber
nivel, ¿qué?
el nivel exacto y para ver cómo porque también quiero que ellos empiecen a ver cómo están preparados para hacer preguntas, ¿verdad?
Sí, son pelados buenos. O sea, son pelados buenos desde el punto de vista.
Julio, your mic is open.
¿Cómo lo viste? Más o menos.
Por lo menos a estos pelados nunca en su vida habían visto la experiencia de cloruro.
Oh, I will launch a new poll with a quick question because I'm curious about the operational systems everybody is using here. So I will launch this new poll just for the sake of curiosity to see which operational system everybody's using their computers. Okay. Oh, okay. So we have Linux users, Windows users. Oh, I see. I see. Francisca said that she's running Julia on Linux, but her machine is a Windows. Okay, I see. Okay. Nice. Let's share. I will share the results so everybody can see and complain about each other's operational system. We won't fight about it. But yeah, it's a fun discussion. Okay, so I think now another question, if you guys were successful while cloning the repository. The repository will be updated and changed during this week because this is a living course and I'm getting experience in teaching and doing those things. So I will be editing and pushing commit to the GitHub repository during this week. You can, so this question is important. When there is an update, do we need to clone the repository again? So it depends. My recommendation for everybody, but this is a bit tricky. If you have experience with Git, you should create a branch to do your own changes. And then you leave the main branch just for the updates from the class. So you can run a Git pull in the main branch every day. Because otherwise you can have merge conflicts when you try to run this Git pull and then you need to clone the repository again. But the easiest solution is to clone the repository again every day of our meeting here. So this is more like up to you. How do you use Git and GitHub? But if you're looking for the easiest solution, is to clone the repository again every day. We are supposed to do this in Git. You can do with Git clone, or you can download the zip. Let me share my screen again, and then I can show you this. So when you go to the repository, you have this code. You can copy this and run git clone, or you can download the zip folder, okay? And then you don't need to go to the command line and type git clone the HTTPS address. No, you just download the zipped folder if that's easier for you. But again, that's up to you. Whatever you feel more comfortable, you are free to use and try it. Okay, let me go back to the meeting. Okay, so okay, so can we get started in the notebooks? I think in the answers, I got most of the people answering that they could do that. That's great. So let's start. Let's get started. I will launch a new poll. I know these are a bunch of polls, but I want to interact with people here, so I think those questions are helpful to do that and understand if everybody is on track and at the same page. So I will launch a new poll just to make sure everybody, just to know if everybody has experience with programming. So yes, new poll is launched. Okay, great. As of now, most of people are beginners. We have some intermediate, and we have some advanced people. That's great. Let's wait for everybody to answer. And feel free to interrupt me, open your microphone to ask questions or make comments. Okay. So yes, we have most of the people are beginners or intermediate programmers. That's great. Okay, so let me share my screen and we start on the notebook. Finally, it was a long and good introduction. So if you open the repository, I'm on VS Code. So if everybody has VS Code, I suggest to open the repository. You just cloned there. You can go to classes and go to day 1. That's the notebook we'll be covering today. And you can see that this is the Julia workshop notebook. Here are some instructions. Some of them I already told everybody about it. So the git clone in the folder called classes, we will be pushing each day's class. We have some practice. I will be pushing more practices to this folder as well. You can open your questions in the issues tab on GitHub. And the level of this workshop is beginner to intermediate. And this is not supposed to say everything about Julia. It's not possible you become a senior developer in Julia in a week. We can practice, understand more of the syntax of the Julia language and try to use in our scripts and practice a little bit. But this is more to inspire and motivate people to start using Julia in their day-to-day work. Because I know many people use Python for scripting. If you work with machine learning and data science, you use for that. To interface with electronic structure software like Orca, Gaussian. Most of the people use Python to do that, but it's possible to use Julia. And I will show some of the benefits of using Julia in all of this. And the goal is to provide resources and the general knowledge of the language, so you can start practicing and using that, and maybe you become a Julia developer and you start creating packages, interacting with the Julia community. And yes, basically today we'll be talking about the background of the Julia language, some of the history of the Julia language. We will be talking about some of the syntax, as I mentioned earlier. And many people ask me how old is the Julia language, because some people just heard about it a few years ago, but Julia is already 10 to 11 years old. Its first release was launched on 2012. So I don't know if someone sent chat message. No. Okay. Its first release was launched on 2012 on GitHub, and I can show you the Julia repository. Julia is an open source language with a bunch of contributors. I made some contributions already in the Julia repository. It's a very fun community. You have a bunch of resources. You have the Julia homepage. You have the documentation. It's a very good documentation. You have the Julia Slack, the Julia YouTube channel, and so on. So I really suggest you to check the Julia GitHub repository because you will see a bunch of resources to learn more. And a curious fact about it, why the programming language is called Julia. And there's no special or specific reason for that. In one of the interviews with the main creators of the Julia language, they said they called the Julia language Julia just because it's a fun name, a cool name. They like it. So, and it was, and interestingly, the name of the language was on one of the first commits in the GitHub repository, which is interesting and great. So they thought about the name before they executed the project itself. And some of the good points about Julia, there is this paper, and it's a really good paper. Julia, come for the syntax, stay for the speed. I think this paper is in the papers folder in the repository. So if someone is interested in reading it, I strongly suggest the read. But some of the good things about Julia is its speed, the multiple dispatch, dynamic type system, meta programming, built-in package manager, built-in test manager, documentation, the parallelism that is built in. You don't depend on third-party software to do that. The built-in distributed computing, the GPU support, multi-threading, and those are things that we will be talking about during the course. I won't explain everything today. And today we will focus on the syntax and configurations. So I will launch another poll just to ask which version of the Julia language you installed. Let's see. Yes, so I've launched a new poll just to see. Okay, 1.9 is winning. Yes, I like it. Okay. I see many people with the 1.9. Some with the 1.7. Okay. Alfredo, did you install using the built-in, okay, apt, built-in repository manager on Linux? Okay, that's fine. The thing about the 1.9 version It's even more optimized for speed, and it's optimized for plotting and the compilation process. It's really great. Yeah, and depending on how you installed it, I always suggest installing Julia via Julia Up. So yes. And okay, so most of the people, I will share the results. Most of the people have the 1.9 version, which is great. We will focus on that during the course. Stop sharing this. No. You'll see that we will start with baby steps. So for people that are more advanced, stick with me. I promise it will be a fun moment, and I would really appreciate if the people that are more experienced with programming in this course could help the people that are more beginners, and we can build something really cool with these interactions. But yeah, we will start from the beginning. Don't worry about it. And the focus is that everybody will be able to follow. And if not, please stop me and raise your hand and tell me, okay, I'm not following. Please go back. And I will do that. So yes. I'm using the Julia 1.9 version. Another cool thing about Julia is the Julia REPL, the real eval print loop. You can run Julia just in time when you go to your terminal. I've asked about the operational system to see if people have access to their terminal or a command line center prompt. When I go to my terminal, I type Julia, I see the Julia REPL. I can print and interact with the language at real time, which is really cool. I have the version 1.9.0 released this year, which is great. And I will show some tricks here that are really interesting. To exit the Julia REPL, you just type exit and open and close parentheses. Let's go through the Julia configuration. I'm sure everybody who installed Julia has a .julia folder somewhere in their computer. You don't need to find it now that it's cool, you know about it. When you go to this folder, you have the packages installed, you have the log files, you have the conda environments, you have the git clones, you have the compiled code, you have the cache code, the scratch, a lot of things. And you have this config folder. If you go to this config folder, and if you don't have it, you can create. You can make the config. Let me do the following. So I will remove my config. Okay, that's fine. I removed and I will create again. If you don't have it, you can just create your config. That's great. Okay, when you go to the Julia REPL, let's just use the plain and common print function. I will print my name. Okay, print Leticia. And I will type exit. Okay, everything is so like white. There are no differences in colors. between methods, variables, strings, and nothing. Like, it's everything the same color, which is boring, right? But there's a really cool thing you can do when you go to this config folder. You can config your REPL by creating a startup.jl file. In this file, you can do whatever you want that will be initialized every time you run Julia and enter the Julia REPL, which is really cool. So let me, okay. So let's suppose every time I initialize my Julia REPL, I want the Julia language to say hi to me, right? Let's see. Yes, Julia will say hi to me every time I initialize. Okay. I like colorful codes, as you can see here in my VS Code. How do I do that with Julia? I will explain more about the package manager during this class today. But if you have your package manager configured and if you have it installed, you can use a package called my REPL. And then when I do that, and I use the function print, and now it's colorful. I type exit, it's colorful. So it has a difference between the colors of the methods, of the strings, the variables, which is really cool because you can visualize your code better. And here you can see Julia is saying hi. You can do whatever you want to configure the language. Oh, something that is cool. You can, oh, I don't know, why did I erase that? You can put emojis. So Ismail, I think that's it. Let's see if it will work. Nope. Yes, you can put the emojis, but we can take a look at it later. Okay. Let's go back after seeing the Julia REPL in the config folder. You can, and these instructions are in the notebook, so you can create a startup.jl file, and put whatever you want, the packages you want to use. Oh, okay. Now I will go back to the REPL and I can show the package manager. It's really cool. One of the good things about Julia, and for people that know how to code in Python, oh, I see questions in the chat. Yes, yes. Yes, basically because I'm in OS X system. That's true. Okay, so going back to the package manager. For people that are used to Python, you have a lot of complications while installing packages, managing environments, because you can create clone environments and you install packages in one environment, but not in the other environment. And then you have the pip install you have global installations, local installations, and whatever. And sometimes you have conflicts between those. In Julia, you don't have this. In Julia, it's quite easy to manage these packages because you have the PKG. PKG is the protocol to deploy and install packages in Julia. Basically, when you initialize your Julia environment, you type using PKG and you have it. And then you can do PKG add whatever package you want. A common package in Julia is the linear algebra. You type PKG add, and then you will have that installed in your computer. Your alternative is when you are in the Julia repo, you can type brackets from your keyboard, and then you enter the package manager environment inside the Julia repo. And then instead of typing this, you type add linear algebra. Okay. And here you can see where it's installed in your computer and so on. And random. Yes, same thing. So that's the way you manage packages in Julia. No more, no less than this. It's quite flexible and easy to do that. And if you want to call this package, you can type using linear algebra, using random. And what happens if you try to call a package that you don't have installed? Don't worry about it. Let me think about a package that I don't have installed. I think it's the FTK. Yes, I don't have the FTK. It will look for, and this is cool because this functionality here is something that I've implemented in the Julia language. So I always feel happy when I see this. So it found the GFTK package in the registry. Okay. So you want to install it? Do you want to install it? Yes. And then it will compile and install everything. Let me see the message in the chat. Yes, the recording will be shared. I'm working in an institutional proxy. How can I set up a verbal to download and install packages in Julia? I didn't understand your question. By institutional proxy, you mean you are in a company and you have your IP controlled, and oh, I see. Okay. That's a good question. I haven't tried. Okay. Let's do the following. Oh, and I see Jordania's message. So I suggest Jordania to open an issue in the GitHub repository so we can work on that off the meeting hours. And I suggest Ian to open an issue there. I can take a look because I haven't faced this problem. So that's an interesting question. Okay. But are you being able to use it, Ian? Like for the meeting now? Oh, okay. But open there because I want to take a look at this. How to manage and handle. Okay. And Jordania, if you could open the issue for us to help you figure out your Julia installation, that will be great. Okay, going back to this. Okay, everything is compiled. Installation is completed. Fine, great, perfect. Okay. So basically you repeat this process to everything you were doing with the package manager in Julia. Great. Let's go back to the notebook then. Yes. And as I mentioned earlier, Julia is a compiled language, which is something different from Python, for example. Python has an interpreter. Usually its interpreter is written in C++. And I see a message. Oh, what about removing packages? That's a great question. So let's go back here, go to the package manager. When you go here, you type remove, and let's remove the FTK, okay? And it will remove. If you want to update, let me see, let's update random, I don't know. Yes, it will update the package random. You just run update. That's why I really like the PKG environment inside the Julia REPL, because it's very handy. You can manipulate things and update and remove and install very, very easily, which is great. Is that clear? Question so far on this? Great. Okay. Perfect. Okay, so Julia is compiled. And this is different from what Python is, because Python is an interpreted language, and its interpreter makes Python slower than many of the compiled languages. Because when you have an interpreted language, you usually have a very approachable syntax for humans, but not a very approachable machine code or optimized code for the computer to run. And this is different when you have compiled languages. Usually compiled languages are more difficult to learn because of their syntax and the way you manage types and data structures and architecture. But they are really fast, and they are faster than others. That's why in softwares like Orca, Gaussian, Games, we have mostly low-level languages that are compiled, and it's quite tricky to install, and you need a C compiler compiler, Fortran compiler, because those languages are efficient at computing. They're not exactly efficient in terms of productivity for humans to handle and use it, but they're very efficient for computers. Julia solved this issue. This is called the two-language problem, because or you have a very easy language for humans, but very slow, or you have a very fast and optimized language for computers, but very difficult to humans. Julia solved this by by implementing, not creating, but by implementing the just-in-time compilation with a very easy syntax. And this makes the language quite efficient for scientific and numerical computing and fast. Okay, so I will show how this just-in-time compilation works. This means the code is compiled at the time you are running it. You don't need to write the code, then compile everything, and then have it executed line by line. No, in the Julia REPL or Julia code, what you have the line by line execution just in time you are writing and executing, which is great and optimal for productivity and efficiency. I will show here an example of the just-in-time compilation. Don't be scared. I will show some assembly code, some machine code, but we won't be dealing with that. It's just to exemplify and show how it works in the back end. Oh, Julia's compiler, by the way, Julia's compiler is written in Julia, which is very cool. Let's take this. By the end of today, everybody will understand this inline notations, but this is just an example. So this function takes a number and returns the same number if the number is different. If the number is positive, the same number is returned. If the number is negative, 0 is returned. Okay, let me exemplify. So when I try pause 1, it returns 1. And I try pause 2, it returns 2. And I try pause -1, it returns 0. That's what this function does. Let's take a look at the compilation process. In Julia, when you use this macro, this code LLVM in a function, you will see the machine code and the compiled code that is produced. For pause 1, what you have this function calling an integer that occupies 64 bits. And then here you have the conditions. You have the conditions defined. And here you have this machine code telling the computer to return this integer that was provided. Now, let's see what happens if I'm trying -1. When I'm trying -1, basically we generate a similar code, but it will return 0 instead. And if I try a float number, -1.0, you see, let's see the output here. Oh, -1.0. Oops. Yes, Shift Enter. Yes, it returns a float, 0.0. Here it will break the float number, and then it will return a number with the same type, but it will return 0, as you see here. So this is the machine code. This is what happens in the back end when you are running Julia. Okay, that's a lot. That's difficult to read. I promise we won't come back to this, but if you're curious about programming, I suggest you to take a look at it. And if you want to have a more advanced perspective about Julia and programming, this is quite interesting to learn. Now I will show the consequence, the actual result of having this just-in-time compilation to speed up and optimize Julia code. Look at this. This is quite interesting. This is fascinating for me. Let's try to run a for loop in Python. So here I put as a markdown because I couldn't get in the same notebook to run 2 different languages. I would need to open a different notebook. But running this in my computer, running this for loop in Python over a random list and a very long list, what I got, I ran this in 1.73 seconds in Python. The same function in Julia took 1.0 microseconds. And this is we have 2 versions of Julia functions here, and you will be able by the end of this class to understand this syntax. Don't worry about it. This is just to show some of the Julia capabilities. So this code is a pure translation from the Python code. This version here, this function, this get reciprocal. In this function, when you run, you have 1.9 milliseconds, which is, I think, 1,000, 1,000 less than the Python code. When you run get reciprocal 2, this is a Julia implementation with proper Julia optimizations to make the code even faster. Then you have 1 microseconds. And you see that Julia can be 1 million times faster than Python, which is crazy. And the fact that you can translate this directly shows you that you have a very good and approachable syntax. And this high-level syntax makes it faster to code and learn. And the purpose of this is to optimize numerical, scientific programming, and machine learning, which is great. So now, before we start looking at the syntax with more detail, questions so far? You can use the chat. You can open your microphone. Okay, let me launch a new poll. Yes, you can use vectorization in Julia. But I will show this tomorrow actually. But basically the way you go over vectorization in Julia is the inverted way you go using Python. But I will show this in more detail tomorrow. So I will launch a new poll to understand more about the interests people here have regarding to Julia language. And I will okay. So here I'm asking the main interests people have regarding to Julia language. I will just connect my computer to the charger while you answer, and I will be right. Nice. Many people are interested in machine learning. Cool. Some people in numerical computing, and we have 3 folks that, like me, who like software development. That's nice. Share results. Okay. Aditra Roy asked the run button from the VS Code sidebar is not running the code. Any suggestions? Am I missing something? Okay, so let me share my screen and let me try to give you some quick guidance. Are you in the notebook? In the Jupyter notebook?
Yeah.
Okay. When you are in the Jupyter notebook, yeah, you probably need to install the Julia language support. But to run the cell, you can just press Shift Enter, and then you can run the cell if you have everything set up already. So maybe it's this. So try to do this and see if it works. And if it is not working, try to provide more detail and open the issue on GitHub. And then people can help each other on these technical things, okay? And also the recording will be available, so you'll be able to repeat everything, go over it again. Yes, perfect. Don't be ashamed to create issues and ask questions on GitHub, okay? For those very specific things that we cannot go over during the meeting because of time and everything, okay? So let's take a look at the Julia syntax. Let's start slowly. Let's take a look at the print method. By method, I mean a function where you can provide an argument. Okay? So you can do this. You just type print and you put the string. Okay, cool, nice. But in Julia, you also have this print ln. This print ln creates a new line when you are printing. So print ln Leticia, print ln I am 21 years old. See, it creates a new line. If you don't use this ln, everything will be put together. That's the difference when you use ln and when you don't use the ln with the print method. You can provide, so when you have a variable that is attributed to a string, and by variable I mean something you create and you attribute a value, and in this case, this is a string in quotation marks. You see the string in here. You have this variable, and you can also print variables. And you can check the type of the method by using this type of, the type of the variable by using this type of. And then you can check. And you can print the variable. Instead of writing the string inside of the parentheses, you just put the variable. That's fine, and you can do that too. And now let's do some operations with the strings. Here, I have my first name, Leticia, and my last name, Madureira. And then I have the println method. I put my first name. I use this multiplication sign, and I put a space. I put a space in here, multiplication, last name. And then I print, I have my first and last name here. So you can use this multiplication sign to concatenate string, to concatenate things in the print method as well. Now let's use this print method with a for loop. This is cool because if you use just the print method and you create a for loop for letter in name, the variable I created earlier with my name, my first name, you can print the letter. We're using just the print method, so this will be like printed with all the letters together. And if you use the ln method, you will have one letter per line, which is cool. So here you have a vertical name, here in horizontal. I encourage you to put your own name here just to play around with this. I know that's easy, but it's nice to practice. Questions so far? You don't have F strings, and I will show how to put variables in this. But you have LaTeX strings. I didn't put any example here, but for LaTeX, you have this package using LaTeX strings. Let me see. No, it's not configured. Let me do this. KKG and yes. Using PKG. Okay, so you have this latex strings. When you use these latex strings, when you use print, you use this L. Oh, I shouldn't have this. It's fine. Here you have the I've added already. Maybe it's something with my Jupyter, but okay. What you can do, you can use these latex strings to format stuff. But you don't have F strings in Julia, basically. One thing that is cool about Julia, you can use this notation here and press the tab, and you have your nope. Let's do this. Here. Yes. So you can use the Greek letters in Julia as variables. Julia has already stored the value for this, for pi. So that's nice too. You just type psi and you press tab, and you can use these Greek letters as name for variables, which is really cool. Let me just go back to here. Yes. So let's try to play with this. Oh, let me see. Yes, you can use LaTeX behind the scene, but you don't need to. If you don't want, like, you can use this as a print method. You are able to put the variables. I will show how to. Let me see if there is an example here. Yes, there is an example later. Basically, going back to playing with these strings and show some methods with that. You have this sentence, I'm learning Python, and then you split this sentence. This is very close to Python syntax, though. I'm learning Python, and then it breaks this string into 4 strings stored in a vector. Okay? Okay. And then you can strip the exclamation at the end by typing strip sentence and exclamation. Let's try to strip the space. Do this. Weird. It was supposed to work. It was working before. Yes. I know what's going on.
So the error before is because when you are doing this, there's a difference in Julia, just as you have in C, if someone here knows how to program in C, between single quotes and double quotes. So if you do this, you will have an error. And this is a good opportunity to show how to read errors in Julia. Here you have a method error. I will be honest, a bunch of people complain about the errors in Julia, saying that it's difficult to read them. It depends. If you get used to, you can understand, but Julia's compiler is not focused on correctness. So sometimes it's tricky to read them. But here you have a method error. Method because there's an error in this function. In the arguments I passed to this function. Oh, okay. I thought someone had asked something in the chat. Here, I provide this sentence. I am learning Python, and I cannot provide a string because this is supposed to be symbolic. So there's a difference. If I use this double quotes, I'm providing a string. And you can see here, vector string here. And now let's use one of the things that we've learned. All of this is important. All the functions I'm showing are important to debug and understand Julia code. I showed the type of function, and you might think, oh, this is not important. I never use it. But yeah, here's the case you can use it. There's a difference between a character when you have single quotes and when you have double quotes. You have a string. So here, when I want to strip the exclamation, but I put double quotes, I get an error. But when I put single quotes, I get my output without the exclamation. Now, if I want to do this, I can. Let's do the following. Python, let's try. Oh, yeah, I need to provide the character, not the word. P. Yes. When you do this, you always provide the characters. You don't provide the string. And then you can have this working. Now let's use another method for this strings. Let's see if there's Julia, the string Julia, in this sentence. You use the method occurs in to see if Julia occurs in sentence. False, it doesn't. And then for this, you have a Boolean answer, true or false. To make this true, you replace Python to Julia. Then you replace this in the sentence. And then you have, I'm learning Julia. You can just do this. You can just replace one thing for another in the sentences. So yeah, this is quite useful. This is nice, simple. Okay, for some people, I understand it may be boring, a lot of methods, but this is important, and we need to start from baby steps to build things that are more complex. Okay. Here, let's go back to putting variables inside the print method and inside the strings. here, for example, let's define age. 21, type of age. It's a string. As of now, it's a string. If I remove the quotes, it's an integer. If I put dot 0, 0.0, it's a float. Okay, let's go back to string then. Okay, it's a string. And then I need to print. I am, and then I put this dollar, and I put parentheses, years old. And then let's see. Okay, I'm 21 years old. Let's do the following. Yes. Yes. I can make operations inside this dollar parenthesis. If I have the integer here, I can sum up 1. When I have my birthday, I will be 22 years old. And so on. So I can do operations here inside this dollar parenthesis to call things external to the string. And oh yeah, making this variable a string again. How do I transform a string into an integer? By parsing it without going manually and removing the quotes. I use the function parse. Integer age. And then I check the type of age. It's an integer. Here, you can use a package called printf. It's not the same thing as the f string, but you can use this to format your strings as well. Like here, you use this macro, this is printf, and you type pi to 3 decimal places is percentile 0.3f to define 3 decimal places. And Julia understands pi already. And then you print, you have pi to 3 decimal places is 3.142. And you can do this. And you can do 4 more and so on. And let's go crazy. Let's go 100. Yeah, it does it. So yes, now one of my favorite things about Julia, the multiple dispatch. Here, let's see, when you have this variable, this integer number, I gave it 2 as a value. Okay, the type of this integer number is int 64. 64, 32, 16, 8. Those are those have to do with the memory allocations of these numbers in the memory of the computer. So if you're working with GPUs, you will work with 16, 8. When you are working with CPUs, you can work with 32, 64, and so on. That's what this is. And then, okay, I have this integer number. It's an int 64. And I have this decimal number. It's a float number for the computer. And now let me show for the Pythonistas here. In Python, when you define a function, you define def, and you need the indentation. Julia does not require you to have indentation because you have and to communicate that you are ending that function. Just a disclaimer here. Same for loops, as I showed earlier. Here, same for loops. You have this and yeah, so and so on. So here, let's define this function number test. In Julia, when you define the argument inside this function, you can also define the type because Julia is strongly typed. It's dynamically typed, but you can use strong typing. And strong typing is good for the compiler. You can get more optimized and faster code when you have this strong type system. Okay, what we have here. Number test, it takes a given number n, and this number needs to be integer. Okay? Okay. So, I will print this number. I've defined the function, and I provide the number 5. Okay, you can see, okay, I've already learned it. That's simple. That's easy. Now, let me test everybody here in the room. If I provide 3.2 as an argument, let me open a poll. Let me open one and you'll try to guess the output. Error. .2, 3.0, 3. You don't run to see the answer. Try to guess first. Let's see. Okay, good. I'll give more 30 seconds for the people that didn't answer yet. Okay, no one else? Okay, I will close the poll. Let's share. I mean, everybody's seeing because I'm sharing my screen, but yeah. Interesting. 9 people told me that it will give a method error or an error. Other people told me it will give 3 as an output. Let's see. Does someone want to open the microphone to comment on their answer and explain why they pick one answer? One specific answer?
So
Feel free.
basically we are type checking, then there should be an error.
Okay, no pressure. Let's see. Yes, we have a method error. Again, showing how to read this. Method error, no method matching, number test, float. Why? Because it will only match number test, integer. And I'm giving a float. 3.2 is a float. Let's use type of, again, our best friend today. Because in Julia, everything's about typing. So you have this, you cannot use. But here is where the coolest thing about Julia comes into play. Oh, here I have an example with 2.5. Same. Absolutely the same. Method error. Now, let's see. Let's rewrite the function considering the type hierarchy in Julia. In Julia, you have this integer 16, 32, 64. Those are all subtypes of a supertype, abstract, called integer. When you run this, you see that integer 32 is a subtype of integer. Integer 16, int 16 is a subtype of integer. Same for int 64, right? Yes. In Julia, you have these hierarchies. Integer, int 16, int 32, int 64. Remember that here, we wrote this explicitly defining integer, int 64, as the only supported type for this function. But if you want to support all integer types, you rewrite the number test function by providing number test and the argument. You have n and you have this t, m, whatever letter you want. But I usually call it t. This t stands from type, and then this is an abstract type. And what I'm saying is that t is always a subtype of integer. Like in here, it will support integer 16, 32, 64, because I've defined the function this way. Yes. You can also define nothing. You can define the function for any also, okay? And if you define your function for any, you won't have this method errors. If you want to use the more flexible typing system without worrying too much about this, number test, see, you don't have the method error because you are not defining anything. But the goal here is to use this to exemplify the multiple dispatch that will be useful for more complex stuff in the future. So here, okay, I've defined t as a subtype of integer to support all the int types. And I've defined the same function. I've defined the same function, number test, but calling float. And then you tell me, now, whatever number I provide, if it is integer, if it is float, I won't have the method error. In Python, you cannot define these two functions with the same name the way Julia does. And for example, when you call number test 3.2, it will call the one that has float. If you define 3, it will call the function that supports integers. To exemplify this better, let's try to, let me see, print n. Okay. So every time I call number test for integers, I will have it powered by 2. So let's see. I run this. Oh, I see what's going on. It's calling this first version. Yes. Now, let's see. Squared root. Let's see. A. Print A. C squared. Nope. That's just made the same way. This. Let me. Oops. You have 2 ends. You cannot have this 2 ends. You have the number test for integers, for floats, and you run this and you print whatever number. Okay, yes, good. Now, oh, okay. For the floats, this is what I was thinking about showing now earlier in the number test function. But yeah, I already did this here. For the float, you also have float 16, float 32, and float 64. Those are also subtypes. This symbol is for subtype of numbers. Here, when you define oh, I see. When you have this type of, when you have this, you can define a function called type of number. I think int, let me check if int is a subtype of number. Yes, int is a subtype of number. Float is a subtype of number. Integer is a subtype of number. Remember what I just said about the hierarchies. You have number, you have integer, you have floats, and you have like float 32, float 64, and you have int 32, int 64, and so on. So here, when you call this function, you you define this type of number where V, now I'm calling V, is a subtype of number. You use the type of or the variable. If this is a subtype of integer, you print is an integer. Else, you print is a float, and then you close with an end. Again, you always close with an end. Indentation is not required. It's encouraged, but not required. Encouraged for formatting, but you won't face any errors in your code because of that. Using this if approach, you have it's a float, it's an integer number. You can play with that, put whatever number you want. But for the multiple dispatch, you can define the same function with different names. And you can have n being an integer, float, or a string. And you run this type of number, and you put 4 as a string. It's a string, not a number. Now, let's put this. Oops. It's an integer. It's a float. So when you put the float, it will call this function. When you put the integer, it will call this function. When you put the string, it will call this function. This is the multiple dispatch. You overload functions according to the type of the argument. This is a tricky concept, I know, but this is useful for more complex things. And here I have more tests. And in Julia, you can create your own types. And I think that's the last topic for today. But in Julia, you can create your own types. You have abstract types. You have structures. For example, let's suppose you want to create a complex number type. A complex number has a real part and an imaginary part. For this, you create an abstract type. This is a super type, like number, like integer, the ones that I showed earlier. I will call it abstract complex. And then I have the subtype, complex. Complex is a subtype of abstract complex. And I have the real and the imaginary part. And then I have this. And then let's run. If I provide the real part of the complex number being 3 and the imaginary being 2, it will print here. It's a complex number. So after this, I suggest everybody to take a look at the notebook and practice with these functions. Open issues if they have questions. I think this final part we can explore a bit more tomorrow with the data structures. But I want to give a quick overview of the class tomorrow. We'll have a group practice at the beginning of the class. So I will create breakout rooms and we'll have 20 minutes, 25 minutes for the groups to work on this mini project. And then we will discuss, and then we will work on plots and other things tomorrow. And I want to show for today, and this is something that people can test, practice, and play with this code, a mini game where you can try to guess the number the computer generated. Let me show this. This is really cool. And this code where is this? Scripts. This is a code for scripting. So you create a .jl file. We are almost done. You create this .jl file and you use all the concepts we worked today. If else variables, you use this while loop too. It's the same thing, you just put an end. And then this has the error handling thing in Julia with the try catch. It's really cool. Basically, I'm using here the random function in Julia. So the computer generates a number and our task is to provide inputs and try to guess what's the number. And you keep trying until you guess. The number is between 1 and 10. And I suggest you to take a look at this code and try to make your own mini game for it. I will show how this works. To run this script, you do Julia mini game. And welcome to the guessing game. I'm thinking of an integer between 1 and 10. Enter your guess. 2. Oh, I'm lucky. I found out in the first. I'm lucky. Let me try again. I wanna show you other things. So enter the guess. Oh my god. I don't know what's happening. I really don't know what's happening. Okay. Now I I made a mistake on this, but I was lucky twice. Like I figured at the first try. That's impressive. I never can guess at the first trial, the first attempt. So okay, too high. Try again. Let's try 7. Too high. Try again. What happens if I put 4.0? It says invalid input. Please enter an integer because it identifies that this is a float. This is not an integer. So let me put 4. Yes, got it. It's 4. So this is a cool thing. You can go to the scripts folder and play with this mini game. Try to understand the code and try to do your own mini game on this. And tomorrow we will be talking about, we'll have the group activity, and then we will talk about plots. I have one last poll. I hope you liked the poll thing because I did a bunch today. To see if you guys liked. Yes. I launched. Oh, cool. Oh, thank you. You guys are nice. Most people said that they liked. Thanks for that. It's my first time doing this. I know today was more like syntax, simple stuff, the background of the language, but we will be doing more cool stuff, hands-on projects during this course. I hope everybody understood what was talked about, and you can open the issues on GitHub. Feel free to send me emails, play with the mini game, and I see you tomorrow. I'm excited for the breakout rooms, for the group projects, because I think this is a good opportunity for us to get to know each other. Okay, thanks everybody. See you all tomorrow. Sorry for any issues. And I really appreciate everybody's attendance.
Hi Leticia, I have a quick question.